me first give you, let me first give you a few house rules. That is, make sure that your microphone is muted. If you want to ask some questions, please do that via the chat. We will pile up the questions, and in the end of the session, we will have a large Q&A part. Be also reminded that this session is recorded, and be reminded that all the slides of the presenters are saved, and this gives you the opportunity to check the slides also at a later stage. Right, a few words about the project itself. As many of you know, we're involved in an EOSC-Nordic project for the Nordic countries and the Baltic countries, whereby we started to evaluate the fairness of metadata and data published by different repositories in the Nordic and in the Baltic countries. Let's see if I can. Yeah. We had chosen for a series of webinars, and this morning we present step number 5. But let me first show you 2 slides in terms of, let's say, the subject and the highlights of the first steps that we have planned previously. The first webinar was really about the IDs, the PIDs, the importance of a global, unique, persistent, resolvable identifier. Step number 2 was really about splitting the metadata from the data and have the metadata point to the data, and in return the data point to the metadata. Step number 3 was really about standards for, let's say, the minimum requirements of generic metadata. And step number 4 was a guidance in terms of the domain-specific metadata. So what are the minimal requirements that a community should define in terms of their metadata for the community? Now, from those steps, we concluded a few important takeaways, and I'm just going to show you a few of them. First of all, and I've said this before, but I will repeat it, FAIR is not equal to open and for free. The A in FAIR stands for accessible under predefined conditions. So making data fair does not necessarily mean that a researcher or a data owner has to give all his data away for free. The data stays fully under the control of the data owner, and that's an important element, and I cannot say that enough. Secondly, FAIR is not only for the human eye, but mainly there to improve the machine readability or the machine actionability of data and metadata. And the machine has to interpret and understand what is meant. Yeah, I'll say this again. The machine has to interpret and understand what is meant. So it's really about machine actionability. Then the third element, the community or the domain, for instance, the medical domain or the energy or climate control or whichever group that we're talking about, plays an important role in defining the vocabularies, the ontologies, the variables, and other FAIR implementation choices in order to improve the interoperability within the community and to other as well. So all these sessions and steps gave actually some insight and gave some recommendations for the repositories to improve their fairness over time in a step-by-step fashion. Now, if you still want to visit some of these earlier steps, they're all recorded on the Nordic website, so you're free to go there. For this morning, we want to concentrate on the next step, which is step number 5, the value and the limitations of FAIR evaluators. As most of you know, we've used FAIR evaluators in this project to guide the repositories in their journey. And in this webinar, we want to hear from the experts to what extent an evaluator, a FAIR evaluator, can actually help us. How does an evaluator work? What are the no-brainers here? What are the tricky tests? What are clear, undisputed outcomes? And where should outcomes be interpreted and are subject to nuances? All good questions that we have asked ourselves. And let's hear from the experts. So after my intro, we will start with Erik Schultes, giving us an overview of these FAIR principles related to the social aspect, he calls it the blue part, and the technology aspects, which are more the red parts. And Erik will indicate which challenges he sees in evaluating the red and the blue parts and give recommendations for FAIR implementation profiles. Then after that, we'll have Mark Wilkinson. And Mark is one of the founding fathers of FAIR, heavily involved chairing FAIR maturity committees. And he's also the first person to actually have built a FAIR evaluator himself. So it will be absolutely great to hear from Mark and learn from his experiences. Then we have a short break, 5 or 10 minutes. And after that, we continue with Robert Hoover from Germany, talking about the Fuji evaluator that was funded by FAIR is FAIR and developed by the University of Bremen and Pangaea. And this Fuji evaluator is also used in the Nordic project. I haven't seen, I think I see now Robert, so that is good. After that, we will have Hanna Mihai and Thomas Alatera from the Nordic project, showing practical outcomes and reporting real life experience in terms of, let's say, using the evaluator inside the project. And the last speaker is Mark Newson from the Stanford University, giving us also his views, whereby he recommends to concentrate on FAIR at the source rather than the curation of FAIR. And Mark's contribution will be through a video. Because of the time difference, he lives in California. He could not make it on the meeting. So after these experts, we then have a Q&A session, which is guided by Josephine Nordling from CSC. And I will close the event then with a short call to action. So this is the program for this morning. Thank you very much for being with us. And without further ado, I would like to hand over to the next speaker, which is Erik Schultes. And I stop sharing my screen.
Thank you, Bert, and thank you, EOSC-Nordic, for the opportunity to speak today. I'll go ahead and share my slides. And Bert had asked me in preparation, Erik, can you try to give us a helicopter view of kind of the state of the field right now in terms of FAIR evaluators? And so I'm trying to do this today. And I didn't bother to create an aesthetic title. So you have this very long title, but it's actually the outline of the presentation for today. And it's very long because I'm hoping to deliver a kind of overview of the state of the art in where we're thinking about FAIR evaluators. Okay, and I'll start kind of at the beginning. It's also a little bit of a historical overview as well. But I think we're familiar with this idea that back in 2014 in Leiden was a Lorenz workshop where ultimately this idea of the FAIR principles was born. There was a 2-year gestation period where by 2016, there was the paper that was published in Nature Scientific Data, where in box 2 listed these 15 one-liners that we now call the FAIR guiding principles. And it's, I think, notable in that initial publication, there was really like absolutely no commentary at all about implementation. It was really left that, you know, these are high-level behaviors that we would need to see if a machine were to actually be able to do F, A, I, and R on its own. So these are the principles, and it's sometimes useful. So I'll try to highlight that here. It's sometimes useful to partition the principles and what they're asking for by, we call it the red and blue principles, where some of these principles, the red, are properly seen really kind of the domain of infrastructure and infrastructure providers, whereas the blue principles really are, they're asking from the domain researcher solutions there. In fact, in a way, I guess researchers are even sort of obliged to make choices regarding the blue principles. The partition isn't perfect. There's some overlap and there's dependencies, but in general, it can be useful because we can figure out different stakeholders that may be interested in some principles, while other stakeholders may be, more relevant to other principles. And one thing I'd really like to highlight, because I think this was an incredibly valuable outcome of the formulation of the FAIR principles. But principle R 1.3 is asking for data and metadata that meet domain relevant community standards. And I think we'll see in the talks later on today that this is going to be an issue when it comes to FAIR evaluation. And I'm really highlighting also with the box this idea of community. In the work that we've been doing with FAIR implementation profiles, I have concluded, much to my own surprise, that this idea of community is actually somehow fundamental to FAIR. And it could hold, I think, a key to a solution on trying to formulate evaluation tests for principle R 1.3. But those are the FAIR principles, completely left hanging in the air by the original paper. A few years later, there was another article published in Data Intelligence, and this was led by my colleague Annika Jakobsen at the Leiden University Medical Center. But I suspect many of the people on the call today are actually co-authors on this paper. There's a large number of co-authors, and it's really trying to focus on an articulation of, or the interpretation of the FAIR principles. What were the FAIR principles really trying to get at? And can we try and elaborate on that? There was also an interest in trying to take the first steps towards understanding the many considerations, the manifold things you want to think about when it comes time to actually implement those principles. So it's a nice paper. It's broken up into the FAIR principles, and each principle has an interpretation and a consideration. And then, even before that, there was also very nice work done to build a controlled vocabulary around the FAIR principles. And this was expressed or allowed for the expression of nano-publications of the FAIR principles. So trying to make the FAIR principles themselves a little bit more fair. And then starting around 2018, I guess, is when we published this first paper on, we called it FAIR metrics at the time. And when I look back now, I think of this paper on the FAIR metrics is really kind of a more detailed technical interpretation of what's being asked by the FAIR principles. A year or so later, that initial concept paper evolved into what we now call maturity indicators, and the proposal for a series of tests and so real coded testing of maturity indicators around each of the FAIR principles. And then what we see subsequently, and I'm pulling this now, this is a presentation that was given at SWAP 4LS in January. And this is a presentation that was given yesterday by Mark Wilkinson. And we see a proliferation of FAIR evaluation tools, systems, services. And Mark was saying, even in the last couple of months, there's been 3 new FAIR evaluators that have come online. So the idea seems to be well appreciated. It seems to hold a lot of promise. And so maybe we should focus a little bit on the theme for today, which is the value and limitations of FAIR evaluators. And Mark Wilkinson is here today, but I'm also working with him yesterday and this Thursday on a stakeholder meeting for the EOSC task force that is essentially or very close to the topic of today. So in this 1 week, we're having a lot of interesting conversations now with important stakeholders on the issues of fair evaluation. And again, many of you on the call today, I think, are probably participating in the EOSC task force call yesterday and Thursday. But I'm swiping 2 slides here from Mark's presentation yesterday that highlight, I think, some of the value of fair evaluators, or at least perceived value, that there's this explosion and proliferation of evaluators. But there are limitations as well. And Mark is the first to indicate that, a fair evaluation on a resource from 2 different evaluators can sometimes give wildly different outcomes. And this is problematic, to say the least, because it can really kind of undermine confidence in the FAIR principles or in the approaches and where the state of the consensus is. So I would say there's a limitation or maybe a risk right now of divergence, either because everybody's creating new evaluators all the time, or because we haven't really come to an agreement on these interpretations of what the FAIR principles are asking for and how we should actually test them. And I think this is going to be a theme of the week. I already see in the conclusion of the workshop from yesterday that there's a proposal now to have groups who have developed evaluators come together and really try to formulate a consistent interpretation and testing regime for resources. I would like to also mention the work of the RDA Fair Maturity Model Group. So they're also, I think, playing an important role in trying to drive convergence, rather divergence, in fair evaluation. But I wanted to highlight that even there's sort of maturity within the maturity modeling group, in the sense that as of November of last year in the RDA plenary, there was a meeting by the RDA maturity model group that was, I think, a moment where the group is starting to broaden their horizon, or they're starting to look beyond simply defining maturity models, and they're asking what can be done with them. So there's a growing interest in implementation. And we had quite some discussion about this very active approach to FAIRification based on fair implementation profiles. And this is what we've been working on quite a bit in Go Fair. But the idea here, and there's a research article on the fair implementation profile idea, basically for your community, for a given community, a fair implementation profile is just a list of the fair enabling resources that that community has chosen to implement in order to implement the FAIR principles. So in principle, it's a very straightforward thing. It's listing these fair enabling resources that allow you to implement FAIR. But there's I think, in my mind, the FAIR implementation profile is very much related to FAIR evaluation. In fact, it really sort of conceptually grew out of our work with FAIR evaluation tools, because in FAIR evaluation, you're trying to evaluate the fairness of an existing implementation or an existing FAIR enabling resource. Whereas in the FAIR implementation profile context, you're being asked to choose, declare a FAIR enabling resource to implement FAIR. So I really see this as 2 sides of the same coin, in the sense that if we use FAIR evaluators as a tool that would guide an increase in fairness over time, then you do a FAIR evaluation, you get a result, and then you might want to look at, see where you can find gaps, and then try and find alternative implementations that can fill those gaps. The FAIR implementation profile is basically just codifying or formalizing that process. And so behind the FIP, there is actually an ontology we've built, And we've actually have an ontological definition for a fair implementation community, harking back to R1.3, and also these fair enabling resources, which I think in general are the targets of fair evaluators. And we've been able to then package this process in what we call the FIP wizard. It's sort of the data stewardship wizard tool, but repurposed to build a fair implementation profile. And that allows us to publish fair enabling resources, communities, and then that collection, that list, as nano publications. So we can make our fair implementation profiles themselves machine actionable and somewhat fair. Okay, so then coming down to the idea that fair and fair evaluation is not a goal in and of itself, that we're trying to get towards some kind of practical convergence on fair implementations. And one step along that road may be certification. Early on in Go Fair, we produced a concept video about how fair evaluation could play a role in an ecosystem with funding agencies, with other tool providers, repositories, but how fair evaluation might fit in to a kind of certification on data or other resources that allow it to be used or to be given some kind of recognition and status so that people know what to aim for. In the meantime, there was the Fairware project launched by the Research on Research group. And we're going to hear later today from Mark Wilkinson in his video about the work related to a group of 5 funders interested in trying to figure out how fair evaluation and potentially certification can work from the funders' point of view. And then just one other comment on certification. In Go Fair, we have started a pioneer program in what we call Qualification. So Go Fair Foundation itself would never have an interest in the actual certification, but we do feel an obligation to be very explicit about the Go Fair Foundation's interpretations of the FAIR principles and to give some implementation considerations and maybe even to be able to indicate implementation choices that conform to those interpretations. And so there is an interest in the Go Fair Foundation to try and get to qualification criteria, and that's being formulated in a public document that you're welcome to contribute to. Some of you already have, and that qualification document is really a definitive Go Fair Foundation interpretation of the FAIR principles. Not necessarily the best or the right one, but it will be an explicit statement on that. And that is what informs our version of the FAIR implementation profile wizard to encourage the creation of FAIR implementation profiles that would fit these interpretations. So lastly, coming to this idea of convergence, there's a role for the evaluators. If the evaluators themselves can come to consensus on what should be evaluated, there's also a role, I think, for FAIR implementation profiles, where communities can see very clearly how they implement FAIR and how others are implementing FAIR. And we think that this is also an enabler of convergence and choosing better FAIR implementations. And then lastly, just to say that there could be even a nice workflow where we have communities coming together, deciding on FAIR implementation profiles. Because we capture this in a FIP wizard environment anyways, we think we can automatically create data stewardship plan templates that reflect the FAIR implementation profiles of these communities. And then those DMPs can be put to work on the floor to actually implement FAIR in a way that's conformant to the wishes of that community. And then those outputs can be scored by FAIR evaluators. And with that, I would like to say thank you very much for your attention and farewell.
Thank you very much, Eric, for this very interesting presentation on what is going on within the GoFair Foundation and beyond. So as you might have noticed from the agenda, we will take most parts of the questions towards the very end of the webinar, but of course, feel very free to add all questions into the chat in the meanwhile. But without any further ado, let's jump to the next presenter, who is Mark Wilkinson from Universidad Politécnica de Madrid, and he will be giving a presentation on value and limitations of automated FAIR evaluations and defining tests. So warm welcome, Mark, and the floor is yours. Please go ahead.
Thank you very much. Thank you very much to Bert and to Eric for the invitation. Bert has asked me to talk about very specific things. I'm going to jump straight in because I have a lot to say. So the talk is about how to test tricky things and how testing can guide improvements. And so the quote from Bert was, testing interoperability and reusability, so I's and R's, are particularly hard. It would be valuable to hear more about the choices that I made in the evaluator. Now, I'm going to immediately say that there isn't a lot of agreement about how to do this. So for example, in my evaluator, there are 7 tests for interoperability and only 2 for reusability. And in Fuji, there are 4 tests for interoperability and 10 tests for reusability. And this likely reveals that there's a difference in the software author's interpretation of the principles themselves. Personally, the reason that the evaluator has so few R tests is that I believe that most of the R principles cannot be tested in a generic way. So I interpret the R's as being primarily community-centric principles, and as Eric says, we're going to come back to R1.3 a lot. R1.3 says domain-relevant standards, and so I didn't think that I was representative of any given domain, and so I didn't write any tests for R1.3. In my interpretation, I don't want to speak for them, and I know Robert will be speaking next. In my interpretation, Fuji considers communities as a much greater whole and is testing for the use of any registered schema, which is a very, very clever thing to do, I think. And so, there are registries of schemas, metadata standards catalog, fair sharing. Now, I had envisioned that R1.3 would specify a specific schema or standard that was selected by a specific community and that had designed their own metric and their own test. And this difference of opinion, I think, is probably pervasive through the various evaluators, and it likely represents a limitation to the utility of testing, but the tests are pretty transparent in what they do. So the limitation is really in the ability to compare scores across platforms. It's not necessarily in the tests themselves. The tests are doing exactly what they say they're doing. And so I'm not sure if this is really a limitation. If we look at all of the evaluators side by side and try not to compare them to each other, but rather just look at their outputs, I think we get some useful information. So specifically, Bert asked me to talk about how I test some tricky things. So if I look at I1 metadata, use a formal, accessible, shared, and broadly applicable language for knowledge representation. So I have 2 tests, in fact, just 1 test, but a weak version and a strong version. So the test, can the machine find any, let me just switch on a pointer, there we go. Can the machine find any structured metadata, including vanilla XML or JSON or some other structured form? That's the weak test. Can it find it? Knowledge representation language strong test actually looks exclusively for linked data. And again, it's only testing the existence. It doesn't test the content at all. Test I2, use vocabularies that follow FAIR principles. So there's again a weak and a strong version of the test. In the weak test, the machine must find linked data. Predicates from linked data are then filtered, and we can talk about that, maybe what I filter out. But the remaining ones are resolved. If they resolve, they are accepted. 2/3 of those predicates must resolve to pass. Now, this is an arbitrary number, but it's clear in the test documentation that the implementer of the test has to choose what they think is a reasonable proportion. FAIR vocabulary strong, again, you have to find linked data. Predicates are filtered, the remaining ones are resolved, and then if they resolve to linked data, it is accepted. So it's not just that they have to resolve to linked data, and 2/3 of them, again, must resolve to linked data to pass the test. So a weak and a strong version of the same test. I3, metadata include qualified references to other metadata, and really it means outward metadata. So I look for outward links. So the machine first must find link data. The objects of those triples are filtered again. There are things that, for example, structural elements inside of the web page, they have to be filtered out. They're then checked against the domain of the metadata host. So any object URL in a domain outside of the host is acceptable. And in fact, because we don't say how many there have to be, the existence of one is sufficient for my test, which is a pretty weak test, but that's what I decided. R1.1, this is the only principle that I test in the R category. So there's again a weak and a strong. The weak version of the test is that you have to find structured metadata. If there are hash style, so non-linked data style, structured data, I simply do a regular expression test against the word license. If it exists, I accept it. Linked data is then tested for one of these specific predicates. If it's found, the object of that triple must be a resource and not a string. And finally, the strong version is exactly the same as the weak version, except I only accept linked data. I don't accept unstructured, non-linked data, structured data. So going back to R1.3, I said that I expected communities to build their own metrics and tests that fulfilled the R1.3 principle. Now, is that ever going to happen, or is that just wishful thinking? Well, this is happening now. So within the rare disease community, largely because we have a lot of infiltration into that community and we're encouraging them to do this, they've started to build rare disease specific FAIR metrics. So they've got some in the Fs, but also a couple in the Rs and specifically R1.3, where they're actually validating the metadata according to the model that we have within the European Joint Program on Rare Disease. So yes, it's happening, and I love that it's happening. It was always the objective of the evaluator to enable community and domain-specific testing. Anybody, anywhere can register a new test in the evaluator. They can host that test wherever they want, and it was always designed with this objective. So hopefully this is just the beginning. Now, the second thing Bert asked me to talk about, it would be good if you could have some examples where the evaluator has helped to increase fairness levels. Okay, I didn't have a slide deck about this, although I've seen it happen several times. So I decided to do it myself. So I created from scratch a FAIR data point as an exemplar for this meeting. Here's the address of that FAIR data point. I'm pretty sure I've deleted it, so don't try to go there now, but I've screenshotted it. So here's the FAIR data point that I set up from scratch. And then I ran it through an evaluation. This is the commercial interface for the evaluator. You'll notice that I've got the rare disease specific metrics included in my commercial version also. So we test that, and here's the score. So in this version of the evaluator, we split it into F, A, I, and R, and we show the number of tests that are passing in each category. If you click on F, you get the outputs of the Fs. Green is pass, red is fail. And if we open up, for example, this one, the identifier persistence, I've copied the note down here. Testing persistence schemas, so it tells you which schemas it's looking for, and it says the GUID does not conform. Okay, so now I know why that test failed. Look at one of these other ones, metadata identifier explicitly in metadata. And again, we have some information about how to look for that identifier. So it tells us exactly the predicates that it will find acceptable to find the identifier. It found the identifier here, but none of them match the initial GUID presented to the test. So in the metadata, it found a Perl, but I didn't run the test with a Perl. I ran the test with the raw URL. All right. If we look at the A's, metadata persistence was the only one I failed. And again, it tells us exactly what it tested and why the test failed. So In the Duchenne parent project, we actually don't have a persistence policy, so I can't solve that problem. But the evaluator did tell me exactly what I would have to do if I wanted to solve it. The other two problems I can solve immediately, and the evaluator told me that both problems had the same root, right? So the GUID did not conform to a Perl, and the Perl was not being found in the metadata. So I went to w3id.org, set up Duchenne FTP, which is a Perl system using htaccess. So this is what the htaccess file looks like for w3id.org Duchenne FTP, and you'll see that it redirects to the larger, to the actual host name. So if we now look at w3id.org/Duchenne FTP and look at this again, you've seen it already, exactly the same. So what do you think the score will be now? Right. Did I solve both of those F problems? Well, run it through the evaluator. These were the problems originally. And this is going to be an example of why I think testing is so useful. Click on the Fs, you'll notice that I've only gone up by 1 point. So I moved from 5 to 6. So what tests am I still failing? I'm still failing metadata identifier explicitly in the metadata. Well, wait a minute, I thought I fixed that problem. Let's look at the output. Can you see the problem? I'll give you 10 seconds. Spot the error. Well, I started to look for problems in the tests because I couldn't see the error. But then I finally said, you know, I've got to trust the test. The test is telling me something's wrong. There. HTTPS versus HTTP. And so when I updated the metadata, I used the wrong prefix, and it requires an exact match. So I have to be consistent with the GUIDs of my metadata record, fix that, and then finally I get 20 out of 22 tests passing. Right. Now, I built that exemplar from scratch. It took me an hour to do all of that, what you just saw. So starting from a native FTP record, manually improving it for, quote, in real time, just to take those screenshots. And it shows you how you can quickly achieve improvements just via testing. So if I called, for example, Bing to index my FTP, and if I added another triple that pointed at my persistence policy, I would have achieved 100% perfect fairness score on my evaluator in less than 2 hours. And evaluation even told me when I had failed to fix a problem I thought I fixed. So in conclusion, I think fair evaluation is extremely useful in guiding the evolution of fairness for any given resource, but it remains limited in its utility as a scoring system. And that would be due to lack of agreement in the interpretation of the metrics. I do not think that the evaluators are not useful. I think they're all useful. I just don't think that they can be compared at the moment, and that's fine. Okay, so I just want to talk a little bit about my future for fair testing, because I'm hoping starting next month to have some time to go back in and start to rewrite my evaluator. So this week, as Eric has said a few times and took some screenshots, we're having an apples to apples workshop where we've got a wide range of stakeholders that are discussing the appropriate paths to follow to find metadata that can be tested, right? And then also, how are we going to test it? I want to evolve away from fair assessment and towards fair assistance. Right? Bad assessment scores can be very demoralizing, and that is the worst thing we could do to our community. So the evaluator output is helpful, but it's really only for geeks. Right? It's not easy to understand. So what I want to do now is connect the evaluator to the new Fair Sharing API and use it to provide clear and accurate advice on how to solve a test failure. Now, Fair Sharing already indexes the maturity tests that are used. It can link those tests to organizational fair implementation profiles that we also created in Fair Sharing. And we can then automatically update the tests by querying against Fair Sharing and getting information from the FIPS that tell you how people within your community are solving these problems. And finally, if anyone's interested, my metadata harvesting workflow, just for the purposes of the workshops that are going on this week, I've turned it into a web service. So you can now use the evaluators metadata harvester to test your own tests. And you don't have to write, because the metadata harvesting workflow is actually extremely complicated in the evaluator. And so rather than recode all of that, you're welcome to just use mine. And if you disagree with it, please tell me, and I can certainly look at updating it. And so that's really all I have to say. I'll hand back to Eric. So thank you very much for your attention.
Thank you very much, Mark. I see we have some time still before we need to end for a 10-minute break. So I don't know, Bert, do you think we could take a few questions if someone wants to ask the presenters something at this point?
Yes, we can definitely take a few questions. I see it also. We are doing quite nicely in terms of timing, so that's perfect. Can you spot any of the questions that were already?
Yeah, we have first Eric and then Barbara. So Eric first, please go ahead.
Okay.
Well, I just wanted to comment. Mark was mentioning this metadata persistence policy and the idea that there was nothing to score. So had there been a solution for that, he could have attained 100% fairness. In the Fair Implementation Profile Wizard, we have actually created a nano publication that is a kind of like a mini metadata persistence policy. So it's a single assertion that says my metadata is persistent for so much time. And that's a nano publication that is itself pretty machine actionable and referenceable through a unique identifier. So Mark, I would be curious to know, would your evaluator score our nano publication as a bona fide resource for that test?
Yes, it would. If it resolves, yes.
Okay, super. Thanks, that's all.
So now we're at 99% fairness. Thanks to Eric.
Thanks to Barbara. And Tobias.
Yeah, should I proceed?
Yes, please.
So I just want to say that specific nano publication links then also to metadata policy document should link, although that one will not be machine readable. But my question is related to, I think, the last slide that you had, where you said that you would like to link to the organizational FIP that uses resources from fair sharing. So are you talking about the fair implementation profiles, or are you talking about something else here? It links the tests to organizational FIPs that can also be created in fair sharing.
Exactly. So the maturity tests in the evaluator are already registered in fair sharing. And so we can now cross-reference inside of fair sharing between a maturity test and the FIPs that are relevant to that maturity tests. And then again, cross-referencing with a particular community, we can say, right, this test is failing for somebody who's doing an evaluation inside of this community, and therefore this is the FIP that we should use to provide advice.
Okay, I'm just asking because FIPs in the terms of fair implementation profiles as we have minted it, or is this more generic interpretation of what a FIP is? So I don't see yet a connection with fair sharing. We couldn't do that at the time when we were developing it, but it would be really nice to do it. Yeah, so I am wondering if...
I don't understand. I've heard this a few times. I don't understand how you could not do it.
Yeah, it was at that moment not open for us to reuse the resources there, but we can yeah, work on this and improve this.
I was able to get my tests in there and it wasn't open, so I disagree. I'm sort of going to defend them. They're not closed. You just
Yeah,
get an API.
it's fine if this is no more the case. At that stage it was, but it was no problem. Now we can continue and make it better. So the question is, can we combine all these information and work together? That's it. And Susanna already commented on the chat that there is already the chance to do this very soon.
Okay, thank you. I see Anders Barre-Conrad has his hand raised, so please go ahead, Anders.
I thank you. A question for Mark. I like your thought of moving from fair assessment to fair assistance. And my question is that just a matter of label or how we perceive these tools, or does it actually imply a change in how you design evaluator tools?
Well, I don't think it's going to be a change in the metadata harvesting nor the test code. It's really trying to make the output of all of that into something that is actionable by somebody with minimal expertise. So I don't think people should ever have to read the output of my evaluator, as it's a nightmare. But if I can go through at the end of an evaluation, parse through that, figure out exactly what went wrong, and then do a few lookups on fair sharing and give a user-friendly report on, in your community, this is how other people have solved this exact problem. I think that will be much, much more useful than what I'm currently doing.
Thanks. I think that's great. And also at a sort of larger level, because many researchers are very wary that this is just going to be another control regime. So I think it's good to really emphasize that this is actually a tool to help. Thanks.
Okay, and I see Alison Lister has her hand raised. I think this will be the last question we'll take before we end up for a short break. So Alison, please go ahead.
Sorry, I had actually thought I had lowered it again. Mark answered the question really well. I was going to just add a little bit to what he said, but because he answered the question, I meant to lower my hand again. So if you like, go on.
Yeah, perfect. Well, then I suggest we take a 10-minute break to allow you to take some coffees and keep you alert and refreshed. And we'll meet you back at 11 CET. See you soon. Hopefully you can all slowly return back to Zoom. So Bert, should we continue?
Yes, let's continue.
Yeah, let's do that. So hopefully you had a nice little break. We will continue on with hearing about the Fuji Fair Evaluator tool from Robert Huber, who works at the University of Bremen, as well as Pangaea. So Robert has been visited us on a number of occasions before in our FAIRification webinars that we have arranged in EOSC-Nordic, and he is back again with a really interesting viewpoint on the topic. So please go ahead, Robert. The floor is yours.
So, okay, yeah, sorry for the delay. I was a little bit, I thought it would be easier to do it today in the office, but the technology is a little bit different from what I have in the home office. So anyway, so thank you very much for giving me the opportunity to talk a little bit about Fuji again here in this interesting series of events. And Berg today asked me to focus on, well, the limitations of the Fuji Fair Evaluator. And of course, these limitations are not only for Fuji, but also exist for other evaluators. So, oops. No. Okay, now, sorry, my keyboard was disabled. Yeah, just a few words about the context of the work I present. So Fuji, the tool was developed in the FAIR project, and here in the context of a task which focused on the fair assessment of pilots we used for testing what we developed. And in this task, we focused on two main components, the assessment metrics, development of fair metrics, as well as fair tools. And these two components were addressing this this report, Turning Fair into Reality, published several years ago now by the European Commission. Regarding the metrics, we developed our own metrics. So the main reason, I assume this was before I joined the project, was because it was part of the work program, of course. And the result were 17 metrics, which are a little bit different from what Mark and the others have shown. These metrics are, of course, based on previous work done in other projects. Participants have been taken part. And some well-known standards like RDA, data maturity group. And here in this square box, you see one metric which is not tested by Fuji. This is one limitation because we thought it would be really difficult to assess if a record is available no longer and if the data is there. So it is a limitation to test non-existing data sets. For each metric, we have developed one or more metrics, and for each fair principle, we have developed one or more metrics, and for each metric, we have defined one or more practical tests. Here are two examples. So the first test is checking if the identifier is based on a existing schema. This is very similar to what Mark is doing. And the second test is, for example, if the identifier can be resolved, so if it actually exists in the real world. So the definition of tests is in the moment intensively discussed by FAIR stakeholders, and what we decided was to base the individual tests on existing existing standards or best practices. And here is a list of, for example, the basis we used for defining these two tests for these two metrics. You can take a look at this definition in this document, deliverable 4.5, which gives a detailed description on the rationale for each test. So, but the message is that the tests have not been defined on our own decisions, but they are based on published and verifiable criteria or best practices, which are available in the scientific literature. So the result of the test is the Fuji tool. I showed this several times now. It's open source, available on GitHub, and on f-ujinet you can test the tool and find more information about it. Fuji actually is a web service, is a REST web service based on the Open API specification, implemented in Python and using Swagger and Flask. So the output of each test is a JSON document, which gives you information about, actually what has happened. It includes detailed debug messaging information similar to what Mark has shown in his evaluator, to see or to identify what actually the Fuji tool has found in terms of metadata, and it gives you some hint on what did work and what did not work, so you can use this information to improve your metadata. This is a high-level chart illustrating the metadata gathering process. So Fuji is taking an identifier as input parameter and is then trying to extract metadata from the landing page, this etc., which is mentioned in this middle box here, actually, normally I have an extra slide on that. This is including processes like content negotiation, following in linked header links and so on, which allows Fuji to extract metadata from other formats. Fuji is also third-party services like ReadFreeData, and is using information from this repository, for example, to identify if certain standards are supported by the repositories, or if, for example, additional metadata are offered by the repository which offers the data set. So this is a picture which shows the output of the human-friendly web front end we have developed on top of the REST service. It gives an overview on the result of the assessment, as well as detailed information, which is just another serialization of this JSON I showed before, but this is more convenient for users to just see what actually happened, what the results were. Users can save individual results or download the JSON here. You can try it on your own on f-uginet. So Fuji is not the only tool we already know, and that's the reason why we meet these weeks several times. The evaluator presented by Mark is one, and interestingly, these days, some data has been published on Zenodo, which shows the a comparison of results performed on different evaluation tools using these FAIR evaluation services shown here in Fuji. And I think this is interesting to see that, and you all know already, that these tools do not necessarily return the same results. So you can see here, for example, with these where the X and the green and the red fields are, where differences with respect to evaluation results exist. And so this is a limitation of the tool, because you first do not know necessarily why this is the case. These tools may use different metrics. I may use different tests, different software, and the result is then, of course, different result and different FAIR estimates. So what we would need to improve this is, for example, a set of standard samples, sample data sets, which can be used to verify FAIR results, and which can be used to calibrate the tools to be more comparable. So another limitation is the interpretation, or the possibility to interpret the results in general, because there are several reasons why results may differ. For example, a sample may change, so the data set which is assessed may change. So for example, a PIT redirection may have changed, so the PIT resolves to a different landing page, which exposes the metadata in a different way. The software used to support the repository may change, and there may be improvements with respect to the overall fairness. So you may have this in reality, or it may be a result of changes somewhere. And also the procedure of the measurement, the assessment may change, the metrics may change, the scoring method may change, the assessment tool may have different software versions. So these all may change, and it affects the results. So what I show here on the right side of the slides is an example, which is assessment performed on this DOI And in an earlier version, Fuji has a lower score than performed on a later version. This is a result of an iterative process performed on this repository, which led to improvements on both sides with respect to the metadata exposed by the repository, as well as the capability of Fuji to identify this. And well, this is, of course, the ideal way to do this. Another reason for limitations is lack of connectivity. So FAIR architectures in practice always relies on standards which are used in the community. But well, most DOI labeled data sets resolve to a landing page which exposes the metadata to humans. And this may be disconnected from standards like Open Archives initiatives or Catalog Service for the Web or others, which are very frequently used to expose machine readable metadata. So, and as a result, sometimes you lose the connection between the identifier and the metadata. This has been discussed before. So this is a limitation for detecting fairness, which is a result of existing architectures. And of course, a limitation for FAIR assessment is lack of stability. So for Fuji, this is particularly important because Fuji is using third-party resources. I mentioned that before. And during, for example, January, there was the containerization provided by DataSite on DOIs did not work very well, and this also influenced then accordingly the FAIR assessment results of Fuji. So, and this may of course also be the case if other resources which are used by Fuji or the repositories to improve fairness fail. Another limitation is with support for disciplinary FAIR practices. I showed these slides also in another talk here in this a series of webinars. This is showing the OGC ISO family of standards, and you can see that this is a very complex family of standards. For example, for this ISO 1915 family of standards, we have several versions, and for each version you can have several community profiles. One of these is the Inspire directive profile, which is used by the European Commission, which is very important. And as a result, if you use 1939, for example, it may be the case that every XML document you see, which is encoded in this standard, looks a little bit different than another document provided by another repository. And this makes it very hard to actually parse metadata. And if you do deep investigation of fairness, you need to check the metadata content itself. So this is then, of course, difficult to see how fair a repository is, a community-specific repository, in case the standards are implemented in different flavors. So how can we deal with these limitations? Well, this week in parallel is are two meetings taking place. One was yesterday and another one is on Thursday about FAIR evaluation stakeholders meet, and the goal is to actually find the solution how we can improve all of this. And yeah, I hope this workshop today and also the other event together can help us to go one step further into the direction of reaching a consensus how to assess fairness. Thank you.
Thank you very much, Robert. It was really interesting to hear about the tests that you have done and also the discoveries that you've made based on those. So really Really very interesting. Thank you. So next we have a duo presenting for us. So we have Hanna Mihai from DAIC, Danish E-Infrastructure Corporation, and then we have Tuomas Alatera from FSD, the Finnish Social Science Archive, that will present for us on a real-world experience with evaluating repositories. So this will be interesting to hear as well. So please go ahead.
Yes, thank you, Josefina. I start this presentation. So why I'm here is because I'm involved in the EOSC-Nordic work package 4, which is working with FAIR in general. And this part of the work package that I'm talking about now is evaluating the FAIR maturity of Nordic and Baltic repositories. You've probably heard this talk in a different version before, not by me, but by Andreas Janssen, who was the previous work package lead, but he has left the project, so now I'm here. And I'm going to tell you a bit about like how we did this or how this was set up. So we surveyed the Nordics and Baltics for a lot of repositories, over 100. Some were excluded because these repositories didn't have assigned the unique identifiers to each individual dataset, which makes it not possible for the FAIR evaluator to evaluate these datasets. And then we have chosen 10 datasets per repository, which are getting evaluated regularly. We have also run a test to see if this is still what's the word, representative. So if we can really just take 10 random data sets. So we've chosen a couple of repositories that offered OAI PMH access and have evaluated all data sets and compared if the error margin is approximately the same, which it is, so that's great. And now we are doing monthly automated evaluations of these data sets. In the beginning, we also used the evaluator from Mark Wilkinson, and at some point in the project, we switched to the Fuji tool, which you both have heard about now. The workflow that we're using is set in Google Sheets. So we start the analysis there. We can choose, if you can see this here with the false, you can also set that to true. Then we can compare how the evaluation changes in between data site metadata is getting considered or it is not getting considered. There are some Google scripts running in the background where I'm not getting into detail now because I'm not the expert on that. One analysis is taking approximately 20 seconds. We have around 800 data sets in this sample. So one evaluation cycle is taking 4 to 5 hours each. So once with data site metadata and once without. Then this is what we're getting out of it. So we are getting an automated summary for this entire sample where we're getting the average FAI&R score plus the FAIR score and the minimum and maximum output levels additionally with how many data sets have been evaluated. If we want to go into more detail and see a bit more statistics on this, then we have to do this manually afterwards. And what you can see here is the histogram of FAIR scores from one of the latest evaluations. I think this is from December, but I'm not fully sure, but very recently. And you can see that there is a lot of repositories that don't score well at all. And then you get a few that score a little bit better. But what you have to keep in mind is what you've heard now also a few times. It is not necessarily about that you get 100%. It is very important to consider what's important for your repository, for your data sets to see what needs to be changed, where do you have to put in work and time and effort. Does this make sense for your specific case or not at all? These are some preliminary results where you can see the average FAIR score for all data sets going through here, starting in January 2020. For the datasets without datasite metadata and the datasets with dataset metadata. You can see an increase, especially in the I and R scores, if you include the datasite metadata. And what you can also see from this is that you get a slight increase over time, but it's also what Robert said before, it's always a bit complicated to see if when a version changes, is the increase or decrease in the FAIR score actually coming from the sample or from the different version that's been used. So you can see here, for example, in between version 1.12 and 1.35, that there is a significant drop, and after that it slightly decreases again over time. So this is something we have to take into consideration. And now we're just sticking with this version, even though it's not the most recent, to have a good time series where we can then really compare, did it get better or not? And now I hand over to Tuomas. You just tell me when I have to change slides.
Sure, thanks. So hello everyone, Tuomas Aaltonen from FSD, and I mean the project is the same, EOSC-Nordic, and basically the sort of the same setting as with HANA. Next slide, please. So I won't go into deeply into the introductions of who we are, but the Finnish Social Science Data Archive has 20+ years of experience in data archiving and opening research data, so that we are in the let's say in a correct territory here. And already before the FAIR came about, we have always been strong in metadata, and that includes production and sort of a development and reuse. So I would say that the starting point is fairly good. What has been pointed out, and I think it was happening in the chat right now, is that it is clear, and it should be understood, that it's a totally different thing if a data repository thinks about FAIR evaluation, or if it's a research community doing it, because they have different tools, different interests. And obviously the feedback from the research community should affect how the repository sort of does these things, and what kind of metadata changes they need to do, and what kind of vocabularies and ontologies to use, and so on. So FSD is a partner in EOSC-Nordic, and we all our task in Work Package 4 is to support various providers with these FAIR evaluation and also core trust seal certification issues. But at the same time, we are one of those about 100 evaluated repositories, and one of those with an API to test all our metadata records. So our internal goal in the process is obviously to be fair and perform well in the evaluation. Next slide, please. So this is how the experience has gone so far, and obviously the project still runs about a half a year, so the final emoji is yet to be revealed. But the starting point 2 years ago obviously was, as I said, that well, we had already familiarized ourselves with the metadata, I mean the FAIR requirements, and we had done a kind of a preliminary human assessment, and our sort of expectation was that, well, we are quite fair. We know that there might be some issues with interoperability. With this sort of as a starting point, the initial automated evaluation produced really, really bad results in almost all tests. This was the Wilkinson tool at the time. So it was immediately evident that this is not something that we can just explain away. It must be something that we need to do. So the thing to do, and as Mark was saying, that those feedback messages for the geeks at the moment, they kind of took some time to understand what is wrong there. But quite soon the closer examination of the results produced a relief that the failures as such were not fundamental. They were actually not only either to do with the machine actionability or the way we were able to expose our metadata to the evaluator, for example. So once the weaknesses were identified, we immediately saw great improvement with very justified changes done to our metadata. And this work is still in progress, and hopefully we have further changes in the end. And I should point out that it is while we're doing some of these changes, when I was able to push the Fuji score up, at the same time I was able to push it down on the FAIR evaluator. So definitely not a single path that you need to follow to get higher scores in all tests. Next, please. So the key findings I would like to, I mean, there are a number of other changes we have done, but if and I'm pretty sure that this is true for all evaluators. If you fail in these areas, then you'll probably have to do something, and this is the same for repository or even I mean whoever basically. So if you don't have any linked open data, that's probably a problem because that's what the machines are looking for. And even if you have, if you don't expose that properly, if you don't tell the evaluator or whoever uses your machine readable metadata in what format it is and where, then you also have a problem. And a very simple thing is to do with licenses. I mean, and those are very prominent, obviously. Is that if your license information is there for humans only, then you probably won't score any points from machines. And the solutions at FSD are mentioned on green there. So we added embedded JSON LD metadata in the first stage, and we are still building and enriching that. We have introduced some type links into the metadata header sections, still more to come there. And I mean, this was one of the easiest changes. We just used a machine readable way to declare the CC BY license. One of the initial problems we struggled a lot was that FSD does not use DOIs. We use URNs, and at first that seemed like a battle lost. We felt that we just can't tell any evaluator that your URN is a PED. Well, we've been able to overcome that, but you can still see, for example, in Fuji tool, a clear difference if you just expose your URN to the evaluator. It gives you a better score than if you pick the GUID, even though it is able to pick the URN as a PID there. It's still, you give a slightly slower score there. Next one, please. So to finish up with some lessons learned in the repository view, when not all our metadata is directly downloadable, some require registration. So that means the fairness of the metadata is crucial. And we are not able to tackle those tests that kind of expect to be able to get a hold of the actual data object and dice and slice it and see what's in it. So we have to focus on metadata. The basic steps, they were more or less actually revealed before. Embedded JSON is a simple starting point, I would say, or any other machine readable metadata that you would like to embed or link to. But there I would like to to point out a few things. It needs to be valid, whatever you do. Don't make those stupid mistakes of actually exposing faulty metadata, because that won't pass. It makes sense to provide multilingual metadata instead of, I mean, if you have and if you rely on vocabularies, for example. So that is probably way more useful for the repository than just to have your English or national language one. Well, I actually said produce the valid metadata already, so let's go to the don'ts. And I guess the big thing is, as it has been mentioned already today, don't do it for the evaluator, because I mean, that's a very limited way ahead. You're only able to sort of, I mean, you can definitely trick the evaluator. That's that's something I find interesting, and I've been doing it a lot. But the results are totally silly and stupid. So you'll have to think about what is good for the repository, what is good for the researchers, and focus on those things. And this leads to, don't worry if you're not reaching 100 out of 100 or whatever, because you'll have to think about the results and limitations you can't affect. From the repository point of view, the important thing is that you must not only think FAIR at the moment. You have to think about how you make about how you're able to keep data FAIR over a long period of time. So you need to, as a repository, address these things as well, and they are not in the core of the FAIR, but they are probably in the core of a preservation plan and various documents that you expose to the validator. So it's a moving target. Don't panic if the results change, and it's a good idea to do some cross-pollination and check various validators. Obviously, a good thing to reminder, if you know that your repository will be evaluated by the FAIR score produced by, let's say, Fuji tool, then it probably makes sense to focus on Fuji score more than others. Do I have any additional slides at this stage? Or are we in?
No.
Okay, yes, that's what I thought. We are in the end of my presentation. Thank you.
Thank you very much, both Hanna and Tuomas, for this enlightening presentation. So we have the last presenter for today, and after which we will deal with all the questions and the comments. So next runner-up is Mark Musen from Stanford University in the US. So obviously, due to the location and the time differences, he cannot be here in person, but he kindly did record us a video for us to watch, and you can also find the slides that the video is based on in the Indico page, so the same as the registration page. There you can find all presentations, by the way.
You see it?
Ever since the first articulation of the FAIR principles,
Yes, perfect.
people have been working very hard to ensure that data, when put online, are findable, accessible, interoperable, and reusable. Making data FAIR, as you know, is hard. And assessing whether data, when put online, are fair is also hard. We know that a lot of work has gone into building tools that can assess data fairness. The challenge is that most of these tools have never really found an audience. By and large, scientists don't really want a report card to tell them whether the data that they have generated are really fair. They've already created those data and put them in a repository. No one really wants to hear about problems with data sets that have already been uploaded, problems that really can't be fixed very easily. And there's really no fully computable solution to the question of whether a data set is fair in the first place. And because we can't just look at data and know whether they're fair, we're really in a situation where the only real way of making data fair and being confident in that situation is to make data fair at the source. We know this when we look at the FAIR principles. If we look at the FAIR principles, we can see that most of the FAIR principles actually deal with metadata. Metadata that are assigned global, unique, and persistent identifiers, metadata, or rather data that are described with rich metadata, metadata that are clearly and explicitly reflective of some identifier of the data they describe, and so on. Many of the FAIR principles actually relate to features of the repository where the data are stored. And as a consequence, these are features that are not in the control of an investigator. And so scientists really can't do much with these FAIR principles. They have to assume that the repositories that they are using or that they're being instructed to use will abide by these principles. But what's really challenging is when you look at what's left, you realize that most of the statements about metadata in the FAIR principles indicate that the data need to be described with rich metadata, that the metadata and the data will use vocabularies that follow the FAIR principles, that they're richly described with a plurality of accurate and relevant attributes, that they meet domain relevant community standards. This is all very easy to understand, but it's really hard to know what it means to say that metadata are rich, or to know that domain relevant community standards have been used, or even to know what is domain relevant. And as a consequence, it's really hard computationally to look at a data set, to look at its metadata, and to know whether the corresponding data set is fair. Part of the problem is that despite the reliance on the FAIR principles on good metadata, the metadata in public repositories really, in general, are terrible. Investigators view their work as publishing papers, not leaving a legacy of reusable data. And although sponsors generally require data sharing, they often don't pay for it or allow investigators to use grant funds to pay for it. And creating metadata to describe data sets is really, really hard. Most metadata are authored using spreadsheets which can give some guidance about what the metadata need to contain, but really don't enforce that that guidance is followed, and don't enforce that the community standards that the FAIR principles describe are used. What that means is, when you look online and see the kinds of metadata that annotate some of the reportedly best data sets that are used in science, you see really awful stuff. Here's a metadata sample from the biosample database at the National Center for Biotechnology Information at the National Institutes of Health in the United States. And what you see is the usual association of attribute value pairs, in this case, involves field names that don't seem to make any sense, field values that don't seem to make any sense. And really people would scratch their heads trying to figure out what these metadata are supposed to be saying. And indeed, any kind of a computational system that's assessing data fairness wouldn't know what to make of these metadata either. When we look at repositories like the Gene Expression Omnibus, it's almost comical the number of ways in which the age of a subject is represented in geo. We see age is represented as age and age and age and pop age and age after birth and age in years and all these other ways of describing age. That's because geo, like most repositories, does not use ontologies to provide controlled terms to ensure that the metadata are standardized. And as a consequence, it's really hard to find the records that are relevant. It's impossible to interoperate across data sets, and ultimately the data are not reusable. Because of metadata like these, the data sets are not fair. What can we do about this? Well, the FAIR principles already anticipate that the use of community standards can make a big difference. In my field, which is biomedicine, 20 years ago, the community of investigators who were creating data sets related to gene microarrays, technologies that allow high throughput measurements of the way genes get turned on and turned off, identified the need to create reporting guidelines that would make it possible for other investigators to know what the data that are being stored are and know how to interpret them, know what was done, know how to make sense of those data. What the microarray community did was to recognize that it was important to create a reporting guideline that may indicate what was the substrate of the experiment, what kind of array platform was used, what were the experimental conditions. And the entire community got together and created something called the Minimal Information About a Microarray Experiment, something called Miami, which listed all the things that a third party would need to know in order to make sense of the data that are stored online regarding one of these DNA microarrays. Well, it didn't stop with Miami. The bioinformatics community, working with biologists and folks in clinical medicine as well, began to create reporting guidelines for all kinds of experimental situations. They created the Minimal Information About T-cell Assays, or MIATA, minimal information required in the annotation of biochemical models, or Miriam, MiniMES, MISFISHI, and scores of other reporting guidelines that are now widely used in the biological community. These are exactly the kinds of community standards that we need to structure metadata, exactly the kinds of community standards that the FAIR principles refer to. If we want to make data fair, we need good metadata. And we need to make those good metadata at the start, when data sets are first annotated and before the data are even put online. These good metadata need to be based on ontologies that use controlled terms that tell us exactly what we mean when we describe the values relevant for the metadata. They need reporting guidelines like Miami and all those other ones that provide standardized structures for the metadata components. And they need technology that makes it really easy to author good metadata that are compliant with the reporting guidelines and that use the ontologies to ensure that the metadata are standardized. And we need procedures that can create community-based standards for metadata in the first place. But I would argue, if we really care about data fairness, we don't really need to measure data fairness after the fact. What we need to do is make the data fair from the very beginning. And we do that with technology that we've created at Stanford called CEDAR. CEDAR allows investigators to encode standard community-endorsed reporting guidelines using templates that provide a fill-in-the-blank authoring environment where investigators can simply enter values for the various fields and create a standard metadata structure. And whenever possible, those values come from ontologies that provide standardized values for each one of those fields. And this is what CEDAR looks like. It allows you to browse a library of reporting guidelines or templates, and you select the one you want. And we, for example, can populate the biosample human template. And what we see is that we get a reporting guideline that consists of a set of attributes or fields that need to be filled in. Biosample human wants to know what is the sample name, what's the organism, what's the tissue, what's the sex, what's the isolate, and so on. And CEDAR allows us to fill in these blanks using terms from standard ontologies that come from a repository of scientific ontologies that we also maintain at Stanford. You'll note that one of the things that CEDAR does to expedite the ability of investigators to fill in these web forms is to make sure that whenever one selects a field whose values come from an ontology, the items are listed in the order of likelihood to be selected based on our analysis of previously entered metadata. So we can see that when the organism is Homo sapiens, it's most likely that the tissue type is blood. And it's also likely that it could be liver or bone marrow. And the user is going to have the most likely selected terms at the top of that list to make it easy to make the right selections and to make selections that are not random strings, as we saw in that example from the gene expression omnibus, but rather terms from ontologies to make sure that we have a standard template that's being filled in with standard values. And we find that people all over the world are now adopting CEDAR as the basis for ensuring that metadata comply with community standards, both in their structure and in their content. And we see CEDAR being used to support COVID research in the Netherlands, COVID research in the US, neurobiology research in the UK, tissue mapping in the US, cell signaling research, genomics research, and lots of others. What's exciting for us is the recognition that we have technology that will help us create fair data, because fair data depend on good metadata, and good metadata require the community-based standards that CEDAR supports. Not only do we need standards in general, we more specifically need ontologies that provide controlled terms. We need reporting guidelines that provide the uniform structure, and technology like CEDAR that makes it easy to author good metadata in the first place. But we need more than technology. We need those very community-based standards that are at the heart of the FAIR principles. And in our approach, we've been partnering with the GoFair Foundation, which has pioneered the idea of metadata for machines workshops. These workshops, M4M workshops, are intensive 1 to 3 day participatory sessions that allow groups of scientists and other stakeholders to help articulate what are the kinds of metadata that need to be standardized in order to offer a basis for creating FAIR data sets. And the idea is that in an M4M workshop, stakeholders get together, identify a reporting guideline that's appropriate for the kind of experiment that's being considered, identify ontologies that are needed to create standardized values. And if those don't exist, they build them. They create a new reporting guideline, they build new ontologies, and ultimately what we have is a new CEDAR metadata template for a particular class of experiment in a particular discipline of science that relates to appropriate ontologies that can provide standardized values for the terms needed to fill in that reporting guideline. Ultimately, we've experimented with CEDAR. We're increasingly convinced that the way to create data fairness is not to assess fairness after the fact, but to make metadata that are fair at the source. That means standardizing metadata structures using common templates that relate to community authorized reporting guidelines. That we have controlled terms filling in those templates taken from standardized community authorized ontologies. And we have technology like CEDAR that makes it easy for investigators to fill in those templates to create standardized searchable metadata that ultimately will ensure that their data sets are fair. And I believe until we recognize the importance of creating FAIR data from the very beginning, from the time that data are annotated, we're not going to have FAIR data. We know that our data sets currently are not fair, and probably the way to ensure that data become fair in the future is technology such as CEDAR and metadata for machines workshops that will ensure that we have the necessary community standards and the technology that will assist investigators in filling out those standards so the data sets are fair and our data are of maximal value to the scientific community. Thank you.
Okay, thank you, Hanna, very much for helping me out with the video there. So I see we have one raised hand, and then we'll take a few questions that I've tried to insert into the document that we have to see how many we can take. We are a bit lagging behind of time, but first, Carlo Lagagnina, please. You have your hand raised.
Hello, thank you very much for the presentation. Maybe I'm biased in thinking it, but as far as I understand from the presentation, it looks like we are looking for a common standard for making interoperable different data sets from different disciplines. As I would say that way forward is to take advantage of what are already the standards that are available within communities, and communities have those standards available specifically for communities that needed to speak with different organizations within, and it's climatology, astronomy, and health. Those communities have already their standards. Then once we have those standards well in the landscape, then I would suggest then to consider to have a mapping across standards instead of creating new extra standards that I think it's impossible to agree across disciplines. The only way to agree for something is to have the similar goal. I understand that FAIR is a similar goal, but I don't think it's enough to create a standard across all communities. That's it.
Yeah, I don't think that is the purpose. Also, it is not. We're not trying to build one big standard, but it is at least important that within a community that there is a certain standard, and then of course that can be mapped to other standards. There's absolutely no no issue there. And you're absolutely right. We should not try to boil the ocean, as the Americans say. Do it community by community, and then that's hard enough.
Yes, please, Barbara, you have your hand raised as well.
Yes, I wanted just to say, I think CEDAR is a great tool to use the standards that already exist, but connect the standards with vocabularies and then provide the metadata records in a fair way. So I think that's what it helps. And sometimes you have to add additional metadata fields, which are on purpose for a specific project, a specific community. And so you can enlarge it, but still be compatible with the standards that are widely used.
Thank you, Barbara. We have quite a lot of questions in the chat, so I just picked out a few. You can also find some of them in the document that we use for note-taking. So first of all, we have a question. I don't think it has been answered in the chat just yet. It's from Angus White, a question for Eric. Could you please expand on organizational fair implementation profile? What kind of organizations are using FIPS?
Yeah, so Barbara and I have just concluded in January an upgrade of the FIP Wizard, and then that was immediately road tested with the FAIR community. And I think this is now their third iteration of building their FAIR implementation profiles over 2019, 2020, and now 2021 or 2022, depending how you count it. And it's just to really kind of flag the FAIR community as being a very early mover in this and a real supportive developer of the idea. But in addition to the Earth and Earth systems and environment communities in FAIR, we have a pretty broad interest. I think when we ran a series of workshops in 2020 in preparation for the CoData Convergence Symposium, we ended up with 25 different communities, and those were spanning biomedical domains, climate, meteorology, and other Earth environmental systems. We also have an interest now in groups that are starting to wonder and contemplate what would it mean to create a FAIR implementation profile, not so much for a legal organization, but for a topic. So for example, the Dutch Cancer Foundation is very interested now in what it would take to build a FAIR implementation profile for cancer research. And this would be something that would be useful just for researchers within the Dutch Cancer Foundation. But the idea would be that our Dutch national funder, ZonMV, would likely this authoritative FAIR implementation profile from an organization like the Dutch Cancer Foundation, and then apply it to funded research topics at ZonMV, also dealing with cancer-related topics. So there's a broad spectrum of interest, cross-cutting many different disciplines. But just as a reminder, the real hope here is that the FAIR implementation profile can be a tool driving convergence on standards and implementations for FAIR. I hope that answers it, Angus.
Thank you very much, Eric. I would be inclined to say that we can take one more question before we wrap things up. And unfortunately, we weren't able to address all the questions, but you have the document with all the contact information from people joining this webinar. So if you would like, you can pick things up offline. I will try to capture all the discussions going on in the chat and insert into this document. So another question, if we can just briefly take that one as well, it's from Marianne Grothveld from DANS. she asks a fairly big question. So how to encourage more communities to sit together and agree on standards? And she refers to a Science Europe work that was done already 4 years ago, which promoted community standards with regards to data management plans. And it was really hard to get this organized. So anyone would like to reflect on this one? Not an easy question. So maybe we can just think about it instead and maybe continue on discussions at another time. I feel there is a huge need for that, being so many participants also in this webinar and a very lively discussion, which is really nice to see. Bert, what do you think? Should we hand it over to you for some closing
that is
words, perhaps?
Yes, that's very good. And in terms of answering the question, I was thinking about it. We see now a lot of communities actually teaming up, whether it's in the climate control or whether it's in the energy section or whether it's in the medical section. We've seen it in the infrastructure setting also. And it is, my feeling is that we see this now popping up almost everywhere. I would guess that over the next 18 months or so, we will see more and more of those specific domains actually defining, their metadata, and also it will be easier then, for instance, to turn this into data management plans, which can then be used by the different researchers. So there is this trend. How quickly it will go, we do not actually know, but it is actually happening. Okay, just 1 minute in terms of call of action for the repositories here on this call. And let me close by saying that I want to ask, or I want to thank the speakers, of course. I want to thank the organizers. I want to thank the moderator also. And I trust that all of us have really now received a lot of info in terms of the importance of, let's say, making sure that the metadata and the data paths are fair, are becoming more fair. And that also we understand better the relevance of the role of an evaluator in that whole process. As Mark and Robert also indicated, an evaluator can help in a relatively short time to increase the fairness of the metadata and of data sets. So as a call to action for the repositories, I ask you either to take these actions yourself in terms of looking at the way that the metadata and the data is actually stored within the repositories. Either do things yourself or present recommendations from all these different steps to the superiors, to your teams, to take action on it, so that we can over time improve the fairness of all these repositories in the Nordic region and in the Baltic countries. If you need any more help, you know where to find us, and we're more than happy to assist. So by this now, I close the webinar a little bit late, and I wish everybody great lunch. Thank you very much.
Thank you. Bye all.
Thank you.